Cybercriminals are opportunistically targeting industries that continue to operate full tilt during the coronavirus shutdowns, and their attacks have grown more sophisticated. Given this shifting landscape, taking the appropriate countermeasures becomes paramount. Mimecast Email Security 3.0 helps you evolve from a perimeter-based security strategy to one that is comprehensive and pervasive with cyber resiliency in mind. From the company that stops at nothing to block cyber threats, Mimecast is offering a fully featured 90-day web security service. Visit securityweekly.com/Mimecast to learn more. Today's networks are changing fast, and employees, devices, and infrastructures are more distributed than ever. Gigamon Threat Insight is a cloud-native, high-velocity network detection and response solution that's purpose-built to enable you to get in front of this transformation. Learn more at securityweekly.com/Gigamon. Enterprises struggle to detect advanced attacks quickly and thoroughly as evolving threats continue to evade current security tools. Skillful threat detection starts with diverse, high-value security telemetry to run detections on. The Chronicle platform allows security teams to store and analyze petabytes of data in one place so that you can quickly apply powerful detection rules against all of your security data. Learn more about the Chronicle platform and the latest threat detection capabilities at securityweekly.com/Chronicle. Welcome back, everyone, to Enterprise Security Weekly. Security Weekly, in partnership with the Cyber Risk Alliance, is excited to present Security Weekly Unlocked on December 10th, 2020. The inaugural edition of Security Weekly Unlocked also celebrates Security Weekly's 15-year anniversary and will feature talks from Ron and Cindy Gula, Kevin Finisterre, Vivek Ramachandran, and many, many more. The agenda is live at securityweekly.com/unlocked. There are tracks for offense, defense, and other community-based hacking information, and all those tracks are chock full of awesome stuff. We've got some new sponsors we've added to the event that will be doing guided demos with the Security Weekly staff. Mostly Matt and myself will guide the vendor demos, and there's some really cool stuff that we'll go through in the demos, in addition to cool talks. And it is a completely free event, so make sure you go to securityweekly.com/unlocked. This segment is sponsored by Uptycs. To learn more, please visit securityweekly.com/Uptycs. Joining us today is founder and CEO Ganesh Pai and solutions engineer Julian Wayte. Welcome, gentlemen.
Thank you.
Hey, Paul,
Nice to have you on the show today. I would like to start with a little history on the company and also the kind of the state of Osquery. I find it interesting that many of your detections are directly based on Osquery, but also kind of extend that into different areas. So if you wouldn't mind maybe starting there and filling us in on the happenings on Osquery.
Sure. So on Uptycs, we are a Boston-based venture. We are Series B, 4 years into the making. As you correctly surmised, we leverage Osquery for providing a broad array of security analytics. Specifically, to your point, it's an open source agent, which we've adopted as a means to collect telemetry and then action it at scale for a wide variety of detection-centric use cases. But what we primarily do with it is by deploying it on both your productivity endpoints, as in your Mac and Windows laptops, and your production endpoints, as in servers or containerized environment. We have a unique model how to harness the telemetry emitted by Osquery and then action it for a wide variety of detection-centric use cases.
Fantastic. And Osquery supported on Mac, Windows, and Linux, correct?
That's correct. Osquery came out of Facebook. It was originally announced probably sometime in 2015, and it has become among the more popular open source tools. If you go to GitHub security showcase, it's probably among top 5, if not definitely top 10 on a consistent basis if you were to go by the likes. But what's more important is the number of contributors, forks, which is actually showing you that there is a lot of activity around it. To your point, yes, it was originally built as a building block system, if you will, and day one designed to run on a diverse set of operating systems, most common of which are Mac OS and Windows, but it also runs on multiple Unix flavored operating system like FreeBSD and NetBSD. But importantly, it's been built in a way such that you can ask a wide variety of questions by using it as, in some ways, like Lego building blocks. It's got a series of SQL tables. You can do joins across these tables, and that results in a variation of telemetry which addresses a wide variety of use cases.
It's interesting. I want to ask why not the Windows event logs, but then your next question is why would you ever ask about Windows event logging, because it's pretty atrocious. But I think it comes down to your point, Ganesh. The ability to ask it questions is difficult when you look at even syslog from traditional Linux or Unix systems, and when you look at the Microsoft event logging, asking it questions is difficult, correct? Is that the major benefit to Osquery?
That's right. There are two ways to think of it. When you think of it as event log, what goes into a log has been predetermined by the author or whoever has generated the log, which means that most log forwarding systems then in turn will say that I'm going to ship this log in entirety and then impart structure after I ingest it into a SIM. And if there are only two attributes of interest in that log for you, what you've done is you've essentially taken the entire log, shipped it, potentially wasted bandwidth, and then spent a lot of indexing cycles in your SIM or whatever tooling that you have at the back end to like extract the two pieces of telemetry out of a log line, which might have been of high value to you. Instead, Osquery flips the model around. What it does is by taking the artifacts of the system, both in terms of configured artifacts of an operating system, as in, what does the configuration look like in a Linux system in etc host file? What does it look like in etc DNS resolvers file? Or what do the configuration entries look relative to how registries are set in Windows deployment? And it takes all of that static information and converts it into a tabular view. And to what you just said earlier, you then ask the question very specifically, what is it that you're interested? Do you want to have all the system artifacts, or are you just interested in a specific set of artifacts? And it also extends to behavioral state, not just the state relative to configured state. So it's very handy in that sense. It's a building block which allows you to like collect very high fidelity telemetry.
So the underlying operating system doesn't really matter. It's kind of automatically doing that normalization for you to go, these are the users on your systems. Doesn't matter what operating system it was, it does that conversion.
Correct. What it does is it takes the artifacts of runtime, whether it is statical, almost statically configured things which don't change much as a function of time, or things which are constantly changing, as in the behavioral attributes of a system. And it normalizes them and converts them into a tabular view. And then it sends those tables out. And in doing that abstraction, what it does is it creates a thing to say that a configuration is a configuration, whether it's Windows, Mac, or Linux, which means that analysts and observers who are relying on this telemetry and data set are primarily interested in understanding what piece of telemetry do I want. They are abstracted away from what operating system it is coming from.
Matt, you had a question?
Yeah, Ganesh, when you think about different use cases, I mean, obviously I can pull configuration data off. Does that mean now I can start to do things like validate a CIS benchmark in a very consistent way because I've normalized all this configuration data? Can I pull versions of files to see if there's particular vulnerabilities? What are the different use cases I can do with Osquery answering some of these questions?
Yeah, broadly, you can categorize it into two areas. One, you can think of it as a proactive security stance, which is you want to do auditing and probably periodic auditing as a function of some compliance regime that you might be subjected to, right? So to your observation, yes, by pulling out these attributes which tell you if the firewall has been enabled or if the disk has been encrypted, you're able to establish basic security hygiene by looking at these pieces of telemetry. So this is a part of your proactive security, if you will. On the other hand, Osquery also can be configured so that it taps into the behavioral aspects of the operating system. Did someone log in onto a system? Did a socket connection get established? Was it inbound, outbound? Did a file in a certain location which was being monitored, did it change? Did someone go install some additional piece of software? Now, these are all behavioral artifacts of a system which are causing the system behavior to change because the system is alive and something is going on. Osquery allows you to tap into those behavioral changes and stream that data or utilize that data so that you can do reactive detection, investigation, and response. And these behavioral changes typically are leading indicators of potentially something malicious happening. It allows you to take that as an example. If someone launches a piece of software, you can compute the hash of the executable which is being launched and correlate it against a virus total database. If someone does a DNS lookup, you can take that DNS lookup value and then say, is this something which is supposed to be known bad by looking up a domain reputation database? If a connection gets established to an IP address which belongs to a well-known command and control center type thing based on an IP reputation database, you'd be able to correlate that as well. So point is that it allows you to do both reactive as well as proactive security, if you will.
I had a question for Julian in terms of deployment. I imagine, Julian, your role, you're assisting customers in the deployment of this technology. And I think one of the things is we as security practitioners is that time to value, right? So how does the deployment work and how easy is it to get this deployed?
Yeah, the deployment happens in a matter of minutes. It's just a matter of downloading the agent for Linux, Windows, or Mac, and then just pushing that to the machine and installing it. Whether it's 10 machines or 10,000 machines, there's no after-the-fact configuration. It's just a matter of running that install.
And once you deploy it out to your endpoints, does that make it automatically configured to basically make a secure connection back to a cloud instance where it's collecting that telemetry in probably, I would imagine, near real time as possible?
That's right. Yeah, as soon as the installation happens, it'll start sending that information back. Typically, over a 24-hour period, we're staggering the collection of all of the appropriate information, whether it's configuration information that we're collecting every hour, or whether it's every process that's running or network connection that we're capturing, every second. That's how it works.
And that's key. I mean, you go back to kind of where I started the conversation. What I've heard is where it falls down and gets difficult is when you're doing things like Sysmon or Windows Event Logging. That's just one platform. Then you got to worry about the other operating systems. Collecting all that data locally is not terribly difficult, but now everyone's working remote. Of course, we had remote workers before as well. Getting all that securely to a point into the cloud is difficult if you don't have something like an Osquery agent from Uptycs.
Yeah, absolutely. Not only does the Uptycs agent allow you to collect that data in a standard fashion from all the different operating systems, but it allows you to build the detection rules in a standard manner so that if you're looking for certain processes that are run and that are maybe not supposed to spawn other processes, like a Word document is spawning a command line, then you can build those detection rules in a standard manner across Mac, Windows, and Linux as well.
Mm. And is the software inventory also accessible as well? Does it report back a software inventory? Is that a configurable thing?
Absolutely. Yeah, it comes out of the box, so you can see all the programs that are installed on Windows or all the apps that are on your Mac, all the packages that are on your Linux machines or inside of your containers.
Mm. Oh, interesting.
That means you can do vuln detection. Woo! Once I have inventory,
right?
I can do some NVD lookups.
That's exactly right, Matt. That is a pretty important use case. It seems very trivial in hindsight, but the beauty of the approach is that quickly, within a matter of seconds, once you deploy the agent to your observation, you can have all information about the asset, all the packages which have been deployed. And then once you have it in some kind of a correlation engine at the back, to your point, you can start correlating it against NVDB. It's basic hygiene, but the return on that correlation is very high value.
Yeah. I mean, you just think of instant response to a phishing attack. You want to ask the questions of who clicked that link, who resolved that domain, who has this running process, and things of that nature, and who maybe has that vulnerable software that was part of this attack.
That's absolutely right. So in many of our customer engagements, what we notice is that people quickly come to a conclusion that Osquery has high intrinsic value in terms of the fidelity of the telemetry. The ability to action that telemetry seems quite obvious when you look at the data, just like how we are conversing right now. But in practice, when you have to deploy this across 1,000 machines or 10,000 machines and start harnessing that telemetry in a meaningful way and start doing analytics, that's where some of the challenges come into play. And that's where Uptycs fits into the equation, if you will.
Now, you mentioned containers as well. Do I include the Osquery agent in my container builds, and then it's part of all of my running containers that I'm deploying?
Yeah, so Osquery originally was deployed to run at an operating system level, which is to say that if you take the current version of Osquery in the initial release, and Uptycs was very fortunate to be in a position to contribute API bridge that we built between Docker runtime and Osquery. And a couple years ago, our submissions enabled Osquery to get visibility into Docker runtime. Which is to say that by default, Osquery is meant only at an operating system level. It didn't have visibility into what's going on inside the containers. As a phase 2, as a next step towards this, Osquery has been augmented using various instrumentation techniques in an operating system, like looking at audit interfaces and by using what's called as eBPF to get visibility into containerized deployment, which are orchestrated through Kubernetes and other mechanisms. Which is to say that when Osquery gets deployed in the context of what is called as a daemon set, Osquery now has the ability to get a peek into like what's really happening inside the container. And if the container is Docker, CRIO, or LXC, it has the ability to ask a series of questions through introspection of the operating system interface and then find out what's actually happening inside the containers to give you full visibility.
That's really cool. And this also, go ahead, Adrian. Sorry, question.
Yeah. So, Ganesh, you mentioned the challenge of scaling. Installing this on a lot of endpoints. Yes, say an environment with a couple thousand endpoints and your default rule set. How much? What can you expect to see in terms of alerts and things like that? And I guess how easy is it to tune those, to create your own alerts? What does that process look like?
Yeah, so we've built a pipeline-oriented approach. What we do is we use Osquery. Osquery can be configured in a couple of different ways. One, it can be configured to periodically ask questions. Second, it can be configured to capture events which are being emitted by the operating system. And then you can make a decision whether you want to write it to a log or if you want to stream it to a backend. In our deployments, we keep Osquery behavior performant. As soon as the telemetry is captured, we send it to our backend over a TLS connection. When the data arrives, this is where Uptycs starts transforming the data so that it's usable. One way for you to conceptualize what we do is that while the telemetry is in flight, we subject it to a bunch of different rules. And these rules essentially then tell us whether there's any noteworthy signals while the data is in flight. And we try to do this as an example for the couple thousand endpoints that you said. It might be like billions of data point per day, because if it's a busy system, every socket being established, every process being launched, every file being changed could potentially be monitored. Now, by itself, these pieces of telemetry may not be noteworthy. The approach that we've come up with is that subjecting them to rules which are based on the MITRE standard, we generate what's called as signals. And then we do correlations of signals which are tied to like a specific process or tied to a host in a window of time. And then say, do all these things line up well together? And then we say it's a noteworthy detection. So where we fit into the transformation process is telemetry by subjecting to a series of rules is effectively actioned to say that is this a noteworthy detection? And then for our customers and clientele, what we try to do is present the standards using approach such as MITRE ATT&CK detection, right? So that gives them the comfort that Osquery telemetry has been mapped to a well-established standard for doing detections, if you will.
Ganesh, how does this extend out into the cloud where we may not have the luxury of installing Osquery, but we still want that same level of telemetry?
So there are two parts. Cloud, so that I can share some perspective, I can view it from two different perspectives. One is your virtual machine or a containerized deployment where your actual runtime of software is running. The second part is where exactly is this running? Is this running as a managed container service, or is it running in the context of a cloud service provider like AWS, Azure, or GCP? Where Osquery fits into the picture is that it has to be a part of the actual runtime. Now, at Uptycs, what we've come up with is very similar to Osquery. We've come up with other abstractions of query where we correlate what's running inside the machine given the opportunity, or we try to collect as much data as we can from the cloud provider interfaces so that you can do the correlation. If you do not have the ability to get into the operating system runtime, you have the challenges that your visibility will be limited otherwise.
Mm. Yeah,
so
that's the struggle today, right? And probably where Matt's going is I've got some stuff that's on-premise. I've got some stuff that's infrastructure as a service. I'm orchestrating some of my own containers, but I also want to go run my containers in things like maybe Docker Enterprise or Fargate or in Azure. I lose some visibility there. And then I've also got, as part of our application stack, I've got cloud native services, right? I've got Amazon RDS and many, many other services that I want to take advantage of. And the deeper I go into that cloud and the more cloud native I get, the less visibility that I have. It sounds like at Uptycs, you're addressing that issue squarely by saying we want the same things that Osquery can get from an operating system, but we also want that from a cloud provider.
Correct. That's the approach that we are adopting. Independent of us, you said an important consideration. Cloud native organizations, many of them, whether independent of size, whether they're a large enterprise or a small upstart, have recognized the value of this uniform telemetry that Osquery can provide. And they also believe in the abstraction that it can collect telemetry and write it to a file, or in a firewall-friendly manner, transmit it over a secure TLS connection to a backend, right? So everyone out there is trying to leverage this common approach, and that's created a nice environment, not just only for Uptycs and it's benefiting us, but it's also important for others who are not customers of Uptycs because they are getting the benefits of a really popular open source agents and its viability when it comes to like doing detection. Incumbent vendors out there who are popular in EDR tooling for a wide variety of reasons have not been as successful when it comes to like Linux and containerized deployments to date.
Mm. Sorry,
Yeah,
Matt, I didn't mean
true.
to step on you there.
No, but I mean, the use case is really interesting to me because, look, we know we got to collect this data from the endpoint because the endpoint's everywhere. But when you can also correlate that with cloud configuration, the container environment, Kubernetes, now you start to get a broader picture of what's actually going on. And to your point, certain EDR solutions have their strengths in certain areas, but when they've tried to move their technologies into containers or into cloud native, there's limitations because you're stuck to the OS. As you extract that out, I think what you guys have done in the extraction model, but keeping the format the same, gives you the benefit of the Osquery format, but you don't necessarily need the Osquery agent to collect it all. And that creates some really interesting centralization from a, how do I normalize and query all this data in a very consistent way?
Correct, Matt. That's, if I were to say it, I'm a little bit biased, but a very astute observation. The reason I say that is that similar to Osquery, we've at the venture made a decision that all telemetry that we ingest as far as possible from the source will be abstracted in a tabular way such that you can pull the pieces of information relevant to your organization's security needs, both for reactive as well as for proactive security. What that imposes on us is certain amount of discipline to say that from a cloud provider like AWS, can we come up with an approach to say that what's common between AWS, Google, and Azure? And at the end of the day, you might realize that just like an operating system, these cloud providers have config data, they have cloud trail activity, and they have flow logs. These are the three abstractions similar to the tables in Osquery, and there is potential to create a telemetry ingestion system which models very much similar to Osquery, but it deals with the operating system as though it's like a cloud entity, right? Think of AWS, GCP, and Azure as being the three different cloud operating systems which are providing these pieces of telemetry. It enables you to do the same model.
Yeah, and the discipline is always the hard part. So I commend you for it because it's easy to take shortcuts, but if you do it right, then you get the power out of that standard format. And I think that's, hats off to you and the Uptycs team for thinking through that, because that provides a value outside of just the Osquery agent.
That's right. We've been quite fortunate that, of course, it's been some of our ideation to extend this notion to cloud providers and potentially other SaaS services. But it's the customer's interest in this high fidelity tabular telemetry, because what they're placing their bets on is that the fidelity of the telemetry is of high value. Uptycs might be potentially the leader right now in terms of extracting insights from these telemetries, but what gives them the comfort that the fidelity is high enough that tomorrow as their own organization grows, or if they have their own expertise, they'd be able to do the correlation themselves, right? So that abstraction into a tabular view and using SQL inspires confidence in people. When we say it's SQL part, it's not that we have an expectation that suddenly an analyst or an engineer is needed to draw conclusions. It's just that if you're not able to figure out something today, the insights are all right there. You don't need magic. You just simply need SQL awareness to pull it out if need be.
Fantastic. Adrian.
Yeah, so question about you mentioned obviously Osquery is open source. What is the relationship like there? Do you often give back to the open source some of the stuff, additional stuff that you're developing here?
Yeah, we have made a conscious choice to do a fair bit of submissions, and not in all cases do our interests and our customers' interests necessarily align with the stakeholders in the open source community. Where practical, we've made good submissions. As an example, the HTTP 2.0 speedy protocol introduction, so that you can do a lot more transactions between Osquery and a backend, is what Uptycs provided support for. We introduced Docker tables. And then we introduced other elements such as doing a download of an Osquery agent to the next version. Now, some of the users in the community made a decision that they use Chef Puppet to push images out, and the auto updater based on Osquery itself was not of value, right? So these are reasons which are quite pragmatic and understandable as to why the community might make certain decisions. And we try to do our best within those constraints that what the community's interest is. But more often than not, if there are key things, we try to contribute. As an example, we recent past made a submission to get Osquery to be compatible and up to speed with Mac OS Big Sur. That's still a conversation going on with the community, and hopefully the submissions will be accepted. But that's how we typically collaborate with the community.
Fantastic.
Yeah, and just as a follow-up, I think it's very cool, expanding beyond just host OS platforms. Where do you see that going? We saw the move to Mac. I think that was a big one, adding Mac as a in all those Mac specific tables, because with each platform, you get those tables that are only specific to that platform. So you have to do a lot of platform specific work. Now with things like containers and cloud, do you see any other platforms coming in the future? Or is that pretty much, like all the major platforms and you'll just focus on those?
So the notion of a query can be extended to beyond an operating system. As applied to Osquery, and as the name implies, it's OS's operating system query. And it's been ported to multiple flavors of Windows because it's built on the Win32 system. The community, especially under Facebook's guidance, because they were the primary owners up until 2019, some time frame before it was handed over to the Linux Software Foundation. Facebook did a tremendous job to ensure that it gets broad breadth of coverage across many operating systems, and they contributed a significant portion of the tables. Since then, a wide variety of organizations have added support, and it's at that point now where it's fairly stable. But every day you see someone coming up with a new approach to build an abstraction around a piece of data which was triggered by their use case. And that in isolation might, at first glance, may not necessarily look as something of value, but then someone else down the road says, if I can join that table with another existing table, there is tremendous value, right? So there is complete ongoing community-based development. And of course, as applied to Uptycs, we introduce new tables too based on our customer interests. In many cases, they might align with what the community is doing. In other cases, if it's very specific to what someone wants, we try to do our best to make sure that it gets built, and then as relevant, we submit it back to the community.
Outstanding. Julian and Ganesh, thank you so much for appearing on Enterprise Security Weekly today.
Thank you guys for having us.
Thanks for having us.
And also, our listeners can find out more by visiting securityweekly.com/upticks. Thank you, everyone, for listening and watching this edition of Enterprise Security Weekly. We'll see you next time.